If you spend enough time studying Cold War shelter designs, something strange starts to happen. You begin comparing the old engineering world to the modern one, and you can't help noticing a paradox. Today, we have laser-guided surveying tools, advanced concrete additives, waterproofing membranes, and high-speed construction methods. We build faster, cleaner, and stronger, at least on paper. Yet, across the Northern Hemisphere, especially in the harshest climate Scandinavia, Alaska, Siberia, there are Cold War shelters more than half a century old that remain astonishingly intact. Some are still bone dry. Some still hold stable temperatures year-round. Some stand straighter and cleaner today than modern bunkers built in the last 20 years. And the reason isn't what most people assume. It wasn't thicker walls, deeper foundations, or secret Cold War alloys. The real secret is a small, easily overlooked design philosophy that most modern builders never learned or simply forgot. During the height of the Cold War, engineers were designing structures for a world on the brink. They believed these shelters might one day have to hold human life for days, weeks, or even months without outside assistance. And because of that, they had to think far beyond the immediate strength of concrete and steel. They had to think about the enemy that silently destroys every underground building long after the builders walk away. Time. Time brings temperature shifts, freeze-thaw damage, groundwater migration, soil pressure, corrosion, trapped condensation, and subtle movement that slowly cracks even the strongest walls. Decay is relentless. If your design only survives the day of construction but fails 10 years later, it's worthless in a crisis. Cold War engineers understood that a shelter wasn't just a fortified box, it was a long-term environmental system, and that understanding shaped every line of their designs. The first major principle these engineers applied was simple but revolutionary. Don't try to overpower nature, guide it. Most modern shelters are built like sealed capsules. Walls are made thick, joints are waterproofed, and the structure is designed to resist moisture, heat, and pressure with force. The problem is that nature always wins. Moisture will find any microscopic weakness. Groundwater pressure will push harder every year. Soil will expand when frozen and contract when thawed, eventually causing cracks, leaks, and structural fatigue. Cold War builders knew this. So instead of sealing their bunkers tightly, they created pathways-controlled escape routes for moisture and pressure. This is why Cold War shelters often include gravel envelope layers around the walls. Instead of packing soil tightly against concrete, builders created a porous buffer zone. Moisture traveling through the soil hits the gravel and drains downward or outward instead of being forced against the wall. Pressure in the soil equalizes gradually rather than building up. This single concept prevents the two biggest killers of underground structures, hydrostatic pressure and trapped condensation. It also means the walls age slowly and predictably. In Scandinavia, this method was taken to an even higher level. Engineers built double-layered earth berms essentially to layers of soil separated by a coarse gravel bed. The outer soil layer absorbed the brutal winter cold, but the gravel slowed the movement of frost. That meant the inner soil layer changed temperature slowly and gently, protecting the shelter walls from rapid freeze-thaw cycles. Freeze-thaw damage is one of the leading causes of cracks in modern underground buildings, because water inside the concrete expands when frozen. Scandinavians essentially built a giant natural thermal shock absorber around the bunker. Because of this, many Cold War Scandinavian shelters remain almost perfectly dry and crack-free today, while newer structures nearby show frost damage within a decade. Another brilliant idea was treating the Earth not as an enemy, but as a stabilizing thermal mass butt, only if it can breathe. Earth holds temperature extremely well. If you bury a structure properly, it stays cool in the summer and warm in the winter without much effort. But this only works if moisture can escape the soil layers. If moisture gets trapped either from rain, snow melt, or internal humidity, starts creating pressure pockets, ice lenses, and microbial growth. Cold War engineers solved this by inserting permeable layers like sand, crushed rock, or porous volcanic stone above and around the shelter. These materials allow slow but constant air and heat movement through the berm. The result is a structure surrounded not by a static pile of dirt, but by a dynamic, breathing thermal shield that stabilizes the interior environment. Modern builders can recreate this easily using drainage mats, geotextiles, and vapor-permeable membranes. But many don't, because modern construction often prioritizes speed and cost over longevity. Cold War engineers, however, were building for decades of reliable operation. Ventilation is another area where old designs ironically outperform new ones. Today, many homeowners and even some bunker builders seal underground rooms tightly, assuming that airtight equals safe. In reality, airtight equals moisture trap. Cold War engineers didn't rely on expensive fans or complicated systems. They used passive ventilation, which operates purely on natural air movement. A low intake pipe draws cool air from outside. A taller outlet pipe allows warm air to rise and escape. Even a 5-degree temperature difference creates a continuous, gentle airflow cycle. This keeps the interior oxygenated, dry, and free from condensation without using electricity. Many Cold War bunkers with rust-free steel and intact would owe their preservation to this simple, elegant system. Taken together, these principles form an engineering philosophy that modern builders rarely use but desperately need. Structures should work with the natural forces around them, not against them. Cold War shelters lasted not because someone overbuilt them, but because someone understood the quiet, predictable laws of physics that shape soil, water, and air. They used those laws to keep the shelters stable long after their machinery rusted, their power systems failed, and their original purpose was forgotten. The true genius of these designs is that they required almost no maintenance. Once the drainage pads were set, once the gravel envelopes were placed, once the air vents were installed, the shelter essentially took care of itself. Temperature shifts were softened, moisture was redirected, air kept moving, and time became less of an enemy. If you enjoyed this deeper look into the hidden engineering of the Cold War and you want more forgotten designs, survival structures, or historical techniques that still matter today, make sure you subscribe, share this guide, and join a community that appreciates the kind of engineering built not to impress, but to endure.